Hello everyone. So today we will be solving the third problem of this contest, which is count valid sequences, a beautiful maths problem which involves combinatorics with it. So I will be explaining everything in depth, a proof of everything why we are doing it so, right? And before we start, I have written something that is be grateful. Sometimes while we are chasing our dreams, we often tend to forget that we have many things which we should be grateful. So be grateful because we do definitely have enough in our lives, right? Even if you don't have that much, still be grateful because you are alive today, right? That is the biggest reason for being grateful. And as long as you are alive, there are infinite possibilities, right? Because every path will lead to a beautiful destination that you don't even know, right? So be grateful and keep hustling for your dreams, right? Now quickly let's jump to the problem statement. Yeah, before I read the problem, if you feel at any point of the video that you didn't understand it, simply comment it. Either be it a smaller doubt or a like a very good doubt, it doesn't matter, because it is a very great proverb that a fool is the one who didn't ask the question, right? He is fool for once, but the one who didn't ask the question anytime is fool for his life, right? So if you have any doubts, feel free to ask in the comments, right? So let's read the problem statement. The problem states that you are given two positive integers n and k. A valid sequence is a sequence of k positive integers such that the sum of the integers in the sequence is equal to n and the product of integer in the sequence is even. Since the number of valid sequences can be very huge, you need to return a modulo of it, right? And two sequences are different if, for example, 112 and 121 are different, right? And it is pretty obvious, right, that 112 and 121, these two should be considered different, right? So let's first read the terms and conditions, right? What are the terms and conditions for our sequence to be valid, right? So the sequence first condition is should be of length k, right? K should be the length. Okay, the second thing which is there is uh, the sum of all integers should be equal to n, right? So the sum modulo 2 should be equal to it's not sum should be equal to k, right? N rather, really sorry for that. And third condition is the product, that is a1 into a2 into a3 dot till ak should be modulo 2 should give you a value 0. Yes or no? Great. So these three are the conditions that you need to take care of, right? Great. So let's think of the problem. This problem could be solved using DP, but it will lead to a TLE, right? So I think discussing that would just lead to like our wasted of time as well. So I won't be discussing that here, right? There's a mathematical approach to this. Why DP won't work? Because the state, I think explaining it would I don't want it to be half cooked, right? So I don't want to explain it half heartedly. If you look at the time constraints of the problem, n is still 5v5, right? So we need to write a solution because n is still 5v5. We need to write a solution which works in big O of n or big O of n log n, something like that, right? Great. So there comes the thought of maths from it, right? Because once when you read the problem statement and see few test cases as well, you will soon realize that the problem is somewhere needs combinatorics in it, right? So let me first give you the first thought which should be coming is how will you calculate your answer, right? Now to calculate the answer, what I'm saying is, how about you finding the total number of ways to get sum n, sum equal to n? You will say, hey, okay, I can do that. I will say, okay, if you do that, and in that, if you remove all the numbers which make product modulo product odd, right? If you remove all of them which are product odd, then you will get all the numbers that are even, right? This will lead to getting all the valid sequences for us. Yes or no? Read this statement once, that if we get the total number of elements which has a sum of n, And after that, if we remove all the numbers which make the product odd, wouldn't both of the conditions be satisfied? Yes or no? I hope you are getting, because we have the list of all the numbers which are making a sum of n. So the first condition satisfied at this place, and we are removing all the product number, means we are left with even numbers. So we will have the even numbers and the sum equal to n. Yes, great. Now if you understood this statement, let's move to the second step. The second step is also beautiful, and it says how will you find the total number of ways, right? How will you find total ways, right? Now to understand that, think of this. We wanted the sum to be equal to n, right? Sum to be equal to n, and the number and the spots which we had was equal to k, right? Now in our class 11th, there was a chapter called Combinatorics, which taught us how do we separate these things, right? If you don't know, let me introduce you to this. This is called stars and bars, right? This technique is stars and bars. If you don't know, these are just fancy names. Try to understand this so that you can use it in future, right? What does this thing say? Let's say if you wanted to make the sum equal to n, right? That means let's say you had 7 spots. Let's say my sum was 7, right? For example, right? So 1 2 3 4 5 6 7, and let's say I wanted the spots was equal to 3, right? How will you divide this 7 in 3 ways, them in 3 different phases? Either you can place your bar here, second bar can be placed here, one first bar can be placed, let me do with the other color. Let's say second would be this, and this. Still see, this is first bar, first group 1, group 2, and group 3, right? In the previous case you looked at this was the first group 1. This was our second group 2. This was our group 3, right? So by this there can be multiple ways, right? How will you find the number of ways you can do this? That if you have sum equal to n and k spots, so we have a formula for this. If you look closely, how many spaces do we have to place this bar? We just need to place one bar and two bars. We need to place two bars, right? And how many spots do we have 1 2 3 4 5 6 7. These are the number of stars which we had. How many spaces? You can either place a bar at this place. Let me do it with a different color. Let's take the green color, right? So you can place the bar at this place, right? You can place it at this place. You can place it at this place, this place, this place, this place. You can't place it at this place or this place, because that won't form a group as of now, right? Because you don't want it to be a empty group, right? You want some elements inside that, right? So if you count them, that will be 3 4 5 6. There will be 6 groups. And how many bars do we need to place? We need to place 2 bars, right? So here comes the formula for this. The formula for this is to find the number of ways to do this, which we are naming as total ways. That will be n minus 1 c k minus 1. That is, n was 7, so 7 minus 1 was 6 c 2. So these will be the number of possible ways, right? So, and why has this formula come? You can see that we have taken an example from this, and this is the see, because when you have two groups, right, when you have two bars, how many, and you have 6 spots, right? The problem boils down to what? If you had 6 places and 2 bars, how will you place it? How will you place it, right? How will you place it? How many different possible permutations are there to place it? That is nothing but 6c2. Yes or no? I hope you know that, right? To place 2 bars, how many different possible combinations are there? That is nothing but 6c2, right? So this thing is will find you the total number of ways, right? Total ways. Great. So the first part of the problem is covered. Second part of the problem was, how will we find how many pairs, how many sequences leads to odd product, right? Great. So what I'm trying to say is let's look at this using a mathematical proof to it. Really sorry, my mic got disconnected. Yeah, so what I was talking about, how do we call an element? Let's say a was the element, so element a can be written as 2x plus 1, and this defines that the element is definitely an odd number, right? Now to hold that how many elements are there which product is equal to odd, how can we find that, right? Now my claim is, hey, if every element is equal to odd, right, then we can say the product will definitely be odd, right? Let's say 1 into 3 into 5 into 11. If you do the multiplication of this 15 into 11, because if you don't take any even value, the product will definitely be an odd number. Yes or no? Do you agree with me, or yes or no? If you agree with me, now let's write this as, let's say my elements were x1, x2, all of them are odd numbers, right? So the claim is till xk, the summation of all these values will be equal to n, right? Yes or no? If this is an odd number, what I'm trying to do is, I'm trying to let me, if you're getting a bit confused, why have I written this line? Let me explain this to you. What I'm trying to say is, if every number is odd, then only the product will be odd. Yes or no? Product will be odd. Do you agree with me? If you agree with me, if every number is odd, what can I write? The every number, let's say the numbers were x1, x2, x3, dot till xk, right? And now I'm saying the first condition was that the sum should be equal to n. Yes or no? Now the summation of these will be x1 plus x2 plus x3 dot till xk should be equal to n. Yes or no? If you agree with me, now what can I write this x1 as? I can write this as 2k, 2 into, let's say, y, wait a second, 2 into y1 plus 1 plus 2 into y2 plus 1 plus 2 into y3 plus 1 dot till 2 into yk plus 1, and this value should be equal to n. Yes or no? Now see, why can we write this? Because when y1 is equal to 0, the value will be 1. When y1 is equal to 2, the value will be, or rather 1, the value will be 3, right? Yes or no? Do you agree with me? If you do agree with me, now the problem is very clear to you. Now we can write the solution as, if you have any doubt, please do ask in the comments, right? Don't ignore your doubts. You can ask in the comments, right? So we can write it as 2y1. Let's take 2 common from every this factors. We can write it as y1 plus y2 plus y3 dot till yk. Yes or no? And every one when combined k times can be written as plus 1 into k. Yes or no? This sum should be equal to n, right? We are having a maths class now, right? Let's say 2, let's call this element as of now, let's call this as s plus k will be equal to n, right? Now I can write it as 2s will be equal to n minus k, and s will be equal to n minus k divided by 2. Yes or no? Do you agree with me till this point or not? If you do agree with me, then the problem is pretty much clear, right? Now we can have two conditions. The first condition is case 1. See, it is a very beautiful combinatorics problem. So you won't think, you should not be thinking that, hey, the problem should be basic one, right? So the first condition is, what if n and k were same? See, this is not meant to be the solution, but just for your sake of explanation, I'm teaching you this one, right? So let's say n and k were different. They both had different parity. Let's say n was even, right? Let's, for a second, we can take that, right? Let's say n was 8, k was 5. So 8 minus 5 divided by 2 will be 3 by 2. Tell me one thing, if s is the sum, can sum be any given day be 3 by 2? No, it can't be, right? You can do the vice versa of it as well. You can take it as odd and this as even, right? And divide it by 2, still the value is 3 by 2, right? So the values, the first condition is definitely true if n and k were different parities, the number of odd integers or the odd values will be equal to 0. I hope you are on the same pace with me, right? If not, do let me know in the comments, right? Now the second case will be n and k has same parities, right? Now what I have written is s can be written as n minus k divided by 2, right? S can be written like that, right? Now you tell me, how do I find the number of odd sequences using this, right? My S can be written as this, right? What does this mean? Y1 plus, let's say, y2 plus y3 dot 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 should be equal to, this means the summation of all the elements is should be equal to S. That is what S represented to us, right? Now what I'm saying is, this becomes again a combinatorics problem. How? You will be saying, hey, how is this a combinatorics problem, right? What I'm saying is, you want to get, you want to place s elements, and the spots which you have is nothing but k, right? You want to place s elements, or there are s uh, total total star values, right? And you need to place them in k stars. Just now we understood few minutes ago that the formula was n minus 1 ck minus 1, but here the formula will be different. Here it won't work. Hey, you will ask why? Because previously we saw that the value shouldn't be 0. The value should not be 0, right? But here the value of y1 can be 0, yes or no? The value of y1 can be 0, right? Because when y1 is 0, we have written the formula like 2y1 plus 1, right? When y1 is 0, 1 is an odd number, right? So y1 can be 0, right? So whenever that comes the case, then the number of spaces becomes more. Like, let's say you had four stars, right? And you need to place two bars somewhere, right? How many spaces are there? Now this is a space, 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 right? All of them are spaces, yes or no? And the elements itself are also the spaces, right? So the number of spaces become n plus k minus 1, right? And we can use this formula. Now we have n plus 1 minus n plus k minus 1 space stars, right? And how many bars do we need? We still need k minus 1 bars, right? Because it is very obvious. How do we separate them? To separate, let's say, four spaces, we just need one, or and had we had two, we need to spend two bars, or rather we need to divide it into two groups, then we only need one bar, right? To divide it into two groups, we just need one bar, yes or no? So the problem or the formula becomes n plus k minus 1 ck minus 1 to find the number of ways of odd value, right? Now what is n here? N is not the general n is s here. So s plus k minus 1 c k minus 1. And what is s? We can write, we have seen the formula of s was equal to n minus k by 2, right? So the ultimate formula becomes n minus k by 2 plus k minus 1 c k minus 1, right? You just need to find this one, and the initial formula was the number of total ways. So I can simplify it as answer equal to total ways minus this, right? Total ways where n minus 1 c k minus 1 minus this thing, right? And that will be our answer, right? Now I hope you know how to find combinatorics of any given number, right? How we do that? We, let's say if I have written ncr, then the combinatorics becomes n factorial divided by n minus r factorial into r factorial, right? And I hope you know that we can find factorial in big O of n. We can pre-compute it, or we can store that, right? And after finding that, for doing this you need to do a mod inverse, right? Because this number can be very huge, right? So you will be every time doing a modulo. And in when you do a modulo operator, now division value does not remains the same, right? If you don't know about it, it is called Fermat's little theorem. We will be using that only. So if you don't have any idea about that, do drop in the comments. I can make a video on Fermat's little theorem for your clarity, so that you can end to end understand how combinatorics works in that as well. Just the formula, everything else has been taught for what is needed in the question, right? So let's look at the code, and if you don't know about Fermat's little theorem, do let me know in the comments. I will try to make a video on that as well, right? Great. So what I'm doing is, let me clear the screen. Yeah. So if k is greater than n, then the value is almost impossible, right? So let's see, how can we do. We are first calculating the factorial of every number. We are storing it in our vector, right? Then we are finding the total number of ways. Total number of ways is nothing but combination of n minus 1 and k minus 1. Yes or no? I have shown you why we are doing that as well. After that, we will find odd ways, right? Number of odd ways, and we are seeing that if n modulo 2 is equal to, both have same parity, then only the odd ways will exist, right? And we are finding the odd ways. How will we find the odd ways? We are first finding s was equal to n minus k divided by 2. So combination of s plus k minus 1, right? If you look at it, the formula is s plus k minus 1. Yes or no? So we are simply writing that in the code as well. So we find the odd ways, and we valid ways will be equal to total ways minus odd ways plus mod, so that the number doesn't become negative, right? If you have doubts in modulo or Fermat's Little theorem, my brother, sister, whoever is watching, please do drop in the comments that hey, I don't know about it. It's not bad, you can ask it. I will try to make a video on that specially, right? So after that, we will return the number of valid ways, because including Fermat's Little theorem in this single video will be very huge enough, right? So combinations does nothing but finds the combination, like num is fact of num n, and denominator will be fact of k into fact of n minus k modulo mod, right? I have shown you how we find the NCR, right? This is the exact formula, and this is what we are doing as well. So num of num into mod inverse of denominator, right? And how do we find mod inverse? This is the whole process of finding the power. First we find the power, then we do base exponentiation. So after that we get the inverse value of it as well, right? So this was the whole code of it. I hope the problem statement was clear and the solution was clear to you as well. The time complexity of the problem is big O of n. If you have any doubt in the problem or in the code, or any doubt except this problem, you can ask in the comments. I would love to make a separate solution on it, or try to help you out if it's possible via comment only. So thanks for watching. Please do give a like if it was helpful for you, and see you in the next one. Thanks.